this time being VFX and without Indrajit sir. How was it? Okay, as usual, you all are aware of that in the champion series, right? We did an initiative for you all before, like at the beginning of this session. Okay, we always used to keep a teaser. We always used to keep a teaser. Teaser in the sense that gives the introduction about the chapter, right? With the help of the visualizations, how it is going to be, what things we are going to learn, and lots of stuff. Apart from this time when this new victory batch was introduced, first of all, right, I forgot. Hello, bacho. Sat Sri Akal and Namaste from my side. How are you all? So this is Indrajit Singh, your own physics educator. Yes, again, right, Indrajit Singh is back. Okay, Indrajit Singh is back. Okay, with the entire team. Yes, we are back with the entire team, right, with the victory batch for the aspirants. Okay, those who are preparing for JEE and NEET both. So guys, today's lecture will be units and measurement. Okay, let's come to the point. The initiative that you have seen into the beginning of this session, right? Previously, when this batch was decided and lots of discussion was going on, at that time even the brainstorming ideas were coming up in my mind. Okay, so among all of those ideas, I decided let's try something new. Okay, let's give something new to the students that has never been done before. Visualizations has been done by use of the faculty into the very different way, right? We did into the previous batch, that is a champion series. What about the victory batch? Okay, everything right, see, updations are the part, right, of our EdTech. So it is always, I am always in this try of that kind of a thing, okay, that is new and should be introduced in front of the students. So I reached up to the conclusion, yes, this time we have to move on for the VFXN without Indrajit. Okay, so we did that. So if you like this teaser, I will be waiting for all of your comments beneath the video, right? Thanks a lot for your support. Share this lecture maximum as much you can. Share that teaser maximum as much you can, so that the maximum number of the students, right, those who are interested in studying the content into the pure English mode, should aware that something awesome is going on into this channel. Something awesome is going on into this channel, right? So guys, today we are going to discuss as usual units and measurement, the very easy chapter of JEE and NEET. Very easy chapter of JEE and NEET. So are you all ready? Yes or no? Okay, so let's move on to it. See, the bifurcation is something like that way. The chapter contains the fundamentals. Okay, we are going to see the dimensional analysis, right? With the dimensional analysis, right, some part of the errors, the measuring instruments, right, and in measuring instrument we are having Vernier Caliper and Micrometre screw gauge. In dimensional analysis we are having the kind of the three applications, right? Direct question solving approach we are going to see from any respective topic. Okay, what will be that every topic is having its own question solving approach. If you're directly grabbing that approach, now it would be quite easy to solve all of those sums. The maximum number of the sums can be solved using that logic, right? So we are going to see that stuff. We are going to see that stuff. Yes or no? Right? If any technically thing is there, it's okay, right? I have checked that stuff. Okay. Now let's move on to the next part. Okay. It all starts with a story. Okay, units and measurement always starts with a story. A single example we are going to take, and that single example we are going to study, right? We are going to take till end to understand more than 2 to 3 concepts of this chapter. Before moving on to the any concepts in physics, always think what actual the physics is all about. What actual the physics is all about. So it reminds me about a story, right? Story of a Christopher Columbus, right? He was more interested in discovering in India. Arre, sir, how is this so possible? How the Columbus is going to help us, right? Again, understanding what actual the physics is. See, this entire chapter, okay, entire chapter is all about the fundamentals, how measurements are going to done, right? Suppose if you are new, right, and you are seeing, watching this lecture, right? Okay, some students might be having an experience, some students might be having the right concept clear, and so in there for the revision purpose they are seeing this lecture, while some might be completely new, right? They have just transformed themselves from 10th and they have opted out the science in 11th. So for them, right, to move on from the basics, it is important, and that's what we are doing here. Columbus, Christopher Columbus, right? Okay, his voyage, okay, the motive of his voyage to discover India. Finally, at some point, okay, he went off, he passed away, considering the Cape of Good Hope as India. Actually, he discovered the Cape of Good Hope, which was actually in America, right? But finally, he went away, he passed away into the misconception, right, with the myth that he had discovered India. How this example is going to help us in understanding these concepts? How? Right? See here. The first part is Columbus. Columbus is an observer. Columbus is an observer. Right? Columbus is an observer. What he is observing or trying to discover? India. For Columbus, India is a journey of a Columbus to discover India. It is a kind of the process or the phenomena that is going on, and he is analyzing the each and every detail aspect of it. Right. So what is the physics? What logic did Columbus give? Yes, I discovered the India. It is a Cape of Good Hope. Was it correct or wrong? Okay. Was it correct or wrong? Was logic, see, discovering India or discovering the Cape of Good Hope, right? It is a logic. Right? Discovering the Cape of a Good Hope is the logic. Right? Is it correct or not? Physics is all about this thing that is going on. We are the observer. We are in discovery or in analyzing any activity. We are an observer. We are in a discovery of something. We are reading the theory. We are understanding the mechanics. We are understanding the optics. We are understanding the electrostatics. Like you can have an analogy that you are the Columbus, you are the observer, right? And you are trying to analyze each and every aspect. You are trying to analyze each and every aspect. Among that, you found that logic. Is it correct? You actually discovered the India or not? Okay. That the public is going to decide. So all of those things you write it into your journals. When among all, right, someone read your journals and actually went on to Good Hope and found, oh no, this is not India, this is America, right? So at point of time, your logic found was completely incorrect. Your logic found was completely incorrect. So this is the process that we need to follow. Physics is all about understanding the logic, the study of the logic that is going on, right? The logic behind all of those activities that is going on into the surrounding universe. It can be study of the reflection phenomena. It can be study of the sunrise and sunset. It can be study of the kinematics, the moving objects. It can be study of the rigid bodies. It can be study of the distance between or the aspects between the two planets, right? It's all about the study. It's all about the study, right? So this was a basic thing about the physics. Now, what is a physics quantity, physical quantity? Suppose this is an example given in front of you all. This is a Thor, right? The example given in front of you all, he is a Thor, right? Now I must define, right? I must define. We are an observer, right? I'm analyzing one activity. Thor is raising like this way. Who is an observer? You, me. Who is a subject? Who is a suspect? That person. Who is analyzing the activity? You. Are you finding any logic why this Thor is having this kind of electric effect? He is a superhero? No. He is the god of thunder. This is the logic. Now I wrote it down into the journals. Thor is the god of thunder. So for of that reason, I was an observer. I analyzed the Thor. After analyzing each and every detail aspects and after watching each and every movie, I reached up to the conclusion, yes, he is the god of the thunder. Is it right or wrong? I am writing out into the journals. Kindly help me out, right? To just judge me out whether I'm wrong or right. So the logic I found. The name to the logic, it is physical quantity. The factor through which any process is defined is physical quantity. The factor through which any process is defined. Let's take an example. If I'm analyzing this phenomena with how much intensity, right, he is raising up the light, of what wavelength, right, he is emitting the light. Wavelength is a physical quantity. Intensity, right, how much energy he is radiating per unit area, per unit time, it is intensity. So associated with the logic, lots of, right, factors are involved into the phenomena, and those factors are known as physical quantities. What are the examples of the physical quantities? I must say force. Force is the physical quantity, right? Second, velocity, it is the physical quantity, right? Third, acceleration, okay, it is a physical quantity. Momentum is a physical quantity. Angular momentum is a physical quantity. Torque is a physical quantity. They all are nothing else but, right, they are associated with the logic, right, behind any activity that is going on. Associated with the logic that behind the any activity is going on. So this is all the physical quantity is all about. Right. Now let's move on to the next part. After physical quantity, okay, after physical quantity, actually the presentation includes lots of animations. So that's why it is what we can say quite high. Okay, it is on the high mode. It is taking some time to represent that thing. It is taking some time, but it's okay, right? Okay. So the definition of the physical quantity is clear. This is one of the fundamental things we are going on to. Now, what is the classification of the physical quantity? If I'm talking about the physical quantity, right, then basically we have to deal in this chapter with three types of the physical quantity. Okay, the first one, okay, it is all about fundamental physical quantity, right? Fundamental physical quantity. Okay. Second thing you have to deal, right? This is a classification. It is a derived quantity. Okay, and the third one you have to deal with the supplementary physical quantities. Any student might be having a doubt. Any student might be having a doubt why this sort of classification is there. What is the difference between all of those three physical quantities? Why? What is the reason behind it? It's important to understand na, why we have differentiated and named this as only the fundamental. What is an actual reason behind it? Entire physics depends on why and suppose. Okay, this thing we have discussed into the previous sessions. Entire thing depends on, the entire physics depends on why and suppose. If we are analyzing something, we are into the thought, right? If we are analyzing something, we are into the thought, why it happened. So we are understanding the logic behind it. It means we are studying physics. After reaching up to the specific results, right? After reaching up to the specific results, we used to publish into the journals. So fundamental physical quantities, right? Okay, why and suppose. Why this fundamental, why this supplementary, why this derived. Okay, so let's move on to the right, fundamental physical quantities. In entire universe, okay, in entire universe, right, without this 7 fundamental physical quantities, no phenomena is possible. Mass, length, temperature, current, amount of substance, mass, length, temperature, right, amount of substance, luminous intensity, right? 6 quantities are there. Which one is the 7th one? Okay, time. We forgot it. So these are the 7 fundamental physical quantities. Without these quantities, none of the phenomena in the universe is possible. I'm talking about the worst process. Yes, the worst process. What kind of the worst process? See, I'm sitting ideally on the chair. For me, actually, it is the worst process is going on. Ideally sitting, it means I'm doing nothing. Right? So in this worst process also, what mass is stationary. Physical quantity mass is involved. So without this 7 fundamental physical quantities, okay, without no phenomena in universe is possible. Without these 7 fundamental physical quantities, no phenomena in this universe is possible. If you are an analyst, you are analyzing any phenomena, it means anyhow, in any way, among this 7 physical quantity or the combination of this kind of the 7 physical quantities are always involved. Okay, the combination of this kind of the 7 physical quantities are always involved. Always means they are always involved. Right? Always means they are always involved. Now, let's move on to the next definition, that is the derived physical quantity. How we are going to define that stuff, the derived physical quantity. Okay, the combination of more than 2 fundamental physical quantity. Right? So this is a sort of the reason that we got why, right, they are known as the fundamental physical quantities. right? Why they are known as the fundamental physical quantities? Because in this universe, right, okay, without them no phenomena is possible. Okay, now let's move on to the next definition, that is the derived quantity. Okay, the derived quantity. Okay, derived physical quantity, right, it states that, right, combination of two or more than two fundamental quantity, right? Let's have an example of it. Okay, let's have an example of it. If I'm talking about the derived quantities, force, that is equal to mass into acceleration, right? So that is equal to mass into acceleration is velocity by time, right? It is mass, velocity is distance or displacement by time square. So here you can see the three fundamental physical quantities are coming. Kg, right, it is a unit of mass, distance, meter, time square. So here the force is the derived quantity. It is anyhow made up of, right, from the fundamental physical quantities, right? The force is a derived quantity and anyhow it is measured, right? It is, right, okay, made up from the fundamental physical quantities. Now what are the another examples of this kind of the quantities? Okay, torque, R cross F, right, this is a derived quantity. Okay, momentum, P is equal to mv, right, linear momentum. Okay, it is a derived quantity. Angular momentum, L is equal to mv bar, is equal to derived quantity. Intensity, energy per unit area per unit time. Okay, kinetic energy, that is equal to half mv square, right? Potential energy, mgh. Elastic potential energy, half, right, kf square. Elastic potential energy is half kx square, right? Okay, half kx square, right? So these are all of the sort of the examples, right, of the derived physical quantity. These are all of the sort of the examples of the derived physical quantity, right? So first we saw the fundamental physical quantity, then we moved on to the derived physical quantity. Now let's move on. See, derived you all are aware of. Okay, first of all only fundamental physical quantities was introduced, then later on slowly when scientists started, right, researching more and they took interest in the science, right? If I'm talking about 14th or 15th century, then science was not as much developed as was we are thinking right now. At that time Galileo initiated the lot of stuff, right, but he was charged, he was sentenced as blasphemy, right, for going against the whatever the things, for going against the, right, the thought society holds at that time, right, the thought that society was holding at that point of time, right? So at that time science was not as developed as what we are thinking right now. Okay, slowly the centuries went on, the time passed away, right? Many scientists, many people from the different parts of the world took interest in the advancements of the science and technology, and slowly finally they reached up to the results that there exists the supplementary physical quantity. Okay, there exists the supplementary physical quantity. Now what actual the supplementary physical quantity is all about, right? What actually the supplementary physical quantity is all about, right? So the third type of a quantity, it is a supplementary quantity, right? As I told you all, it went on, right, for a long research that there existed two physical quantities without which maximum number of phenomena are not possible. maximum number of phenomena are not possible. If I'm talking about the fundamental physical quantities, then all of those phenomena are not possible without including one among these 7 physical quantities. But if I'm talking about the supplementary physical quantities, maximum number of the phenomena are not possible, right? Maximum number of the phenomena are not possible, which includes first one, right? Plane angle. (2D1) and second one is a solid angle. We are having the very simple definition of the plane angle and the solid angle, right? Having a very simple definition of the plane angle and the solid angle, and we are going to see that. Okay, so we saw physics. See, we started with physics. Slowly we moved on to the physical quantities, and slowly we moved on to the physical quantities and the types of physical quantities, right? With respect to the physical quantities, we are having units. For fundamental physical quantities, we are having fundamental units. For derived physical quantities, we are having derived units. For supplementary physical quantities, we are having the supplementary units. Okay, so fundamental units are the units of the fundamental physical quantities. Supplementary units are the units of the supplementary physical quantities, right? Similarly, the derived units are the units that is formed into the combination of more than two, or right, or more than it in the fundamental physical quantities, right? Now let's see this plane angle. What is an actual definition of the plane angle? Let's analyze that stuff, right? Suppose this is a ground, right? With respect to ground, at what angle, right, this fire is tilted? Okay, this is a tank. In another sense, if I'm talking about its oldest version, then it is a cannon. At what angle, right, the nib of the cannon is tilted, right, with respect to ground? So I want to write it at what will be the firing angle with respect to ground. What will be the firing angle of a tank with respect to the ground? Okay, that will define the plane angle. Simply, if you want to define that stuff, then I must say plane angle is nothing else but an angle subtended by an arc, right? See, let's say this is a point of origin. Angle that radius subtends to form an arc. This is a radius. Angle that radius subtends to form an arc. This is an arc between the 2 points. This is a point A, this is a point B. Right? Angle that radius subtends, right, okay, to form an arc between 2 points. Angle that radius subtends to form an arc between 2 points. That angle subtended, it is known as plane angle. And that is defined as theta, that is equal to arc upon radius, unit of the plane angle, right? It is radian. Unit of the plane angle, it is known as It is a kind of the 2D angle. Okay, it is the kind of the 2D angle. Now, what is the solid angle? If I'm talking about right, what actual is it? I'm taking the example of our day-to-day life. Okay, thousands of times we have moved on to the supermarket, right, or thousands of times we have moved on to the local vendor shops, right, to buy watermelon. We are having all the time, we are having the same doubt whether this is going to be sweet or not, right, whether it's going to be red in color or not. And some might be having a myth: red in color, it means sweet. More red in color, it means it is sweetest. So generally, to clear our myth, right, to clear our doubt, what we used to tell upon the, right, what we used to tell to the vendor, just cut a small part of the watermelon, show it to us. So he pierces knife into it like this way into the 4 angle. Lo saab, dekho, mast meetha hai. Lo. So this is a piece that has been cut. Same if I'm drawing it again, right? This is the same piece that has been cut. Okay. Now suppose this is the origin. We can say like this way, right? This is how the piece is cut and is offered to you to check it out whether it is sweet or not. Yes, I'm talking about the day-to-day life example, right? The pie of watermelon, the slice of watermelon. So here, whatever the 3D angle that is formed, okay, the 3D angle formation, okay, it is the solid angle. This is a symbol of the solid angle. The 3D angle formation, it is known as the solid angle. Okay. The best example is to understand, another example for the solid angle, to understand this concept into the most appropriate manner, is cone. First of all, we are going to write down the formula for this, right? We are going to write down the formula for this to understand this concept, right? This solid angle is defined as dA, in another sense d phi is dA by, right, square of radius, or solid angle, that is equal to area of cross section by square of radius. The unit of the solid angle, it is known as T radian. The unit of the solid angle, it is known as T radian. Right. Now let's see the another example to analyze this stuff into the most, right, what we can say, awesome manner. Okay, let's take a cone. This will show you the relation between the semi-vertex angle, right? Okay, the solid angle and the semi-vertex angle. Okay, I have taken up the cone, right? I have taken up the cone. You all are aware of the semi-vertex angle of the cone. The students of the mathematics are more aware about it. Alpha is a semi-vertex angle. Alpha is the semi-vertex angle of the cone. Now, what is actually the solid angle formed? This is a solid angle form. We can define it as a phi. There exists a relation between the, right, if you want to convert the semi-vertex angle into the, right, if you want to convert into the semi-vertex angle into the, right, the solid angle, then we are having the respective formula. Phi is equal to 2 pi 1 minus cos of alpha. Okay, this is the conversion of, or you can say the relation between the semi-vertex angle and the solid angle. Okay, relation between semi-vertex angle and the solid angle. Right, semi-vertex angle and the solid angle. So this was a very fundamental description regarding all of those stuff. I'm moving aside on the countdown of 10 seconds. If you want to have a note it, right, if you want to note it down, right, you can just pause this video. Okay, so it's 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. That's it. Dimensions. Directly, see, generally what happens here, whenever this units and measurement in some part of the coaching institutes, this units and measurement is completely avoided, because only 1 to 2 questions are going to come up into the JEE examination, and even they are based on the principle of the homogeneity and error. So generally they used to avoid it, or they used to cover it up at the end of the syllabus. And whenever they start this units and measurement, rather than to move on to the fundamental part, they directly jump off to the dimensional formula. Right, they directly used to explain, this is a physical quantity, this is how dimensional formulas are written. This is a physical quantity, this is how dimensional formulas are written, and this is a long list that you have to learn it up. They are having the valid point also, because units and measurement contains, right, the dimensional formulas and all of those introduction to all of those physical quantities that we are going to use up into the entire syllabus of 11th and 12th. So at that moment, okay, students are always in a chaos. At that moment, the students are always into the chaos. How they are going to deal with the formula of the physical quantity that they haven't learned. It would be the first time for you also. It is a crucial task. So for that reason, this thing is kept at the end. Okay. And if it is kept, rather than to move on to the fundamental, but directly they are going to jump off onto the dimensional. It means approximately 40 minutes of the lecture we have crossed, right? Directly they used to jump off on this. Directly they used to jump off on the dimensions. Now what are the dimensions, right? Power to the units of, right, physical quantities. I'm sorry, just hold on. Fundamental physical quantities in it defines the dimensions. They defines the dimensions. Right. Let us understand the concept of the dimension. Let us take an example, right, to understand it well. Suppose this is force. Force is equal to mass into acceleration. Right. So this is kg. This is meter per second square. Here, kg is a fundamental physical quantity. It is a unit of mass. It is having power of 1. Meter is a unit of length. It is having power of 1, right? Okay, in another sense, I can also write this as ms minus 2. Similarly, if I'm talking about the s is second, it is having power of minus 2, right? So this power of, right, this power of, right, are considered as the dimensions, right? This power of are considered as the dimensions. The power of the fundamental physical quantities that are used either to form the any derived quantity or the fundamental, right, whatever it should be. Okay, so those are defined as the dimensions. Those are defined as dimensions. Is it clear, everyone? Okay, is it clear? Okay, this lecture is going to be approximately approximately 3 hours long. Okay, first of all, directly we are going to move on to the dimensional analysis, dimensional formulas, 3 of the applications of it. Then we will going to jump on to the principle of homogeneity. Then we will jump on to the error analysis, and we are going to see the lots of sums of it. Okay, and after that we are going to see the two most important instruments. Those are Vernier Callipers and Micrometre screw gauge, and we are going to end up this chapter. I guarantee the one who is starting from the beginning, okay, and you're going to watch the entire session, the entire chapter will be on your fingertips. I guarantee the entire chapter will be on your fingertips, right? So hope so till now you are completely aware of the formulas of the dimensions, right? Okay, now let's move on to next part. Dimensional formula. The representation of the fundamental representation of any quantities in physics. Representation of any quantity, right, in physics, right, in terms of notations of fundamental physical quantity, right, that representation, it is known as a dimensional formula. That representation, it is known as what? Dimensional formula. Right or wrong? The representation, it is known as what? Dimensional formula. Okay, now how they are going to represent? What is a specific notation for it? What is the specific notation? Okay, we want to represent any quantity in terms of fundamental physical quantity. The notations of the fundamental physical quantity. How we are going to represent that stuff? So for that, I have to write it down first of all, the 7 fundamental physical quantity: mass, length, time, temperature, current, amount of substance, luminous intensity. What is the notation, right, for mass? It is defined as capital M, and power to M is dimensions. M to the power 1, M to the power 2, M to the power 3, that shows its dimension. Length is defined as L, time is defined as T, temperature, it is defined as K, or sometime it is defined as theta. Current, it is defined as ampere. Amount of substance, it is having the notation mole. Luminous intensity is having the notation candela. So these are the specific notation: mass, length, time, temperature, current, amount of substance, luminous intensity. Using this notation, right, we want to represent all of those physical quantities in terms of the 7 fundamental physical quantities. Using all of those notations, we need to represent that stuff. Okay, just hold on a minute. I think we are having the problem with AC. I need to just hold on, right? If you want to just note it down, you can note this down, right? If you want to note this down, you can just note this down. It's not a big deal. Okay, you can just pause this video on the countdown of 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Sorry for this stuff. Okay, now how to represent this stuff? Do we need any example, right? Do we need any example to understand this? Do we need any example or not? Yes, we need any example. Okay, so let's have this. First, Suppose if I want to represent the force in terms of the right notations of the fundamental physical quantity. So first of all, see, it is difficult to represent, or it is difficult, quite difficult to remember all of those physical quantities and its respective dimensional formulas. So rather than to moving on, I'm giving you all a shortcut for it. Remember their units. It is not important to remember the dimensional formula, but it is important to remember its units. With the help of the unit, you can create the dimensional formula. Again, I am highlighting this statement. Kindly mark it up, please. It is not important to remember the dimensional formula, but right. It is not important to remember the dimensional formula, but it is quite important to remember the unit, and as because of that you can create the dimensional formula. Suppose if I am not able to remember the dimensional formula of force, I am aware of the unit. It is kg, right, meter per second square. What is the notation of kg, right? It is m. What is its dimension? That is power 1. What is notation for meter? That is length L. What is its power? That is dimension 1. What is the notation for second? That is time. What is its power? -2. This is the dimensional formula of the force. M1, it is actually abbreviated as M1 L1 T -2. M1 L1 T -2. M1, right? Now let's take another example. Suppose it is momentum. Let's say an example at any moment of the time, if you are not able to remember this formula of the momentum, then how you are going to deal with the stuff, right? If you're not able to remember the dimensional formula of the momentum, directly write it down. P is equal to M, right, into V. P is equal to M into V, right? Okay. So this is equal to kg into meter per second. Kg, it means M. It is having power of 1. Meter, it means length. It is having power of 1. Second, it means time. The notation is T, having power of -1. Right. This is the formula of momentum. This is how any physical quantity is represented in terms of the right fundamental physical quantity, and that notation, it is known as dimensional formula. And again I'm telling you all, it is not important to remember the dimensional formula, but rather than, okay, it is important, okay, to remember the units or its respective mathematical expressions to generate the dimensional formulas. Suppose I'm talking about a very weird physical quantity, voltage. That it is quite difficult to remember this dimensional formula of the voltage. How we are going to define that stuff? Potential difference, right? Voltage, let's say in another sense, potential difference. So we are going to define as V is equal to E into D. Electric field is force per unit charge D. What is the unit of force? Kg meter per second square. What is the unit of charge? That is coulomb. Coulomb is current into time. What is the distance? That is length. So finally, if I am writing up, the dimensional formula of force is M1 L1 T -2. The dimensional formula of distance is L1, right? Dimensional formula of Q is A1 T1. Q is having the formula, that is electric current into time, right? Okay. So from this, directly we are going to identify or obtain the formula of the voltage, right? That is M1 L2 T -3 A -1. Now this is difficult to remember. right? This is difficult to remember, but using the formula, I immediately obtained it. Using the formula, I immediately obtained it. Okay, like this way, the dimensional formulas are always obtained, right, using the fundamental physical quantities. And again, I'm saying it is not important to remember all of those dimensional formulas, but it is important how you are going to create it. Okay, so it is a dimensional formula के पीछे मत जाओ, यूनिट के पीछे जाओ, राइट डायमेंशनल फॉर्मूला झक मार के पीछे आएगी. सक्सेस के पीछे मत भागो, काबिलियत के पीछे भागो, सक्सेस झक मार के पीछे आएगी. इसी तरीके से राइट, डोंट मूव ऑन टू द डायमेंशनल फॉर्मूलाज, राइट, जस्ट प्रिपेयर योर काबिलियत, प्रिपेयर right yourself to remember all of those units and mathematical expressions. You can create the dimensional formula. Let's move on to the very first example of it. What is the dimensional formula of stress? Now, stress is having the physical quantity. The stress is the physical quantity is having the formula force per unit area. Okay, it is defined as force per unit area. Now, force per unit area, it means what? Force is having the dimensional formula m1 l1 t minus 2. Area, it means L square. Area is also defined in terms of m square, na, meter square, centimeter square. So it is going to be the square of length. So what is the formula of stress? m1 l minus 1 t minus 2, right? The symbolic notation of the stress is sigma, and its dimensional formula is m1 l minus 1 t minus 2. Right? So what will be the perfect answer among this m1 l minus 1 t minus 2? D is the perfect answer for this specific question. Let's move on to the next question onto it. The pair of the quantities that is having the same dimensions. Okay. Sometimes it happens, right, that questions can be solved using trial and error method. Sometimes it happens. The questions can be solved using trial and error method. Now, this trial and error method states that each and every option need to be checked out with the question. Each and every option that needs to be checked out with the question to reach up to the correct answer. Here, impulse and surface tension. Impulse is change in momentum, that is equal to force into time. Surface tension, that is force per unit length. Are these going to be equal? Is impulse is going to be equivalent to the surface tension? No. Impulse is not going to be equivalent to the surface tension. Impulse is not going to be equivalent to the surface tension. It means the first option is automatically going to be incorrect. Second, angular momentum and work. Angular momentum is equal to mvr, right? So this is kg meter square per second. Dimensional formula is m to the power 1, l to the power 2, t to the power minus 1. Work, force into displacement, it is going to be m1 l2 t minus 2. Are they equal? No, they are not equal. Is this going to be correct? No, it is not going to be correct. Work and torque. Work is force into displacement. It is m1 L2 T minus 2. Torque, it is defined as R into F. Again, it is going to be m1 L2 T minus 2. Are they equal? Yes, they are equal. The first option is going to be correct, the C1. But we need to check out the last one also. Young's modulus and energy. Young's modulus and energy. How we are going to define that stuff? Fourth one. The formula of the Young's modulus, that is equivalent to pressure, that is force per unit area, that is m1 L minus 1 T minus 2. Energy, it is equivalent to work, that is m1 L2 T minus 2. Are they going to be equal? Wrong. Only C is the perfect answer for this specific question. Only C is the perfect answer for this specific question. Right? This is what the trial and error method is all about. This is what the trial and method is all about. We need to check each and every option with this specific question to reach up to the correct answer. I'm moving aside on the countdown of 5, 4, 3, 2, 1. Right? Oh. You can just pause this video and move. So these were the basic questions on the dimensional formula. Now what is the dimensional of 1? Okay. See, this is an x physical quantity. 1 by under root of mu naught epsilon naught. 1 by under root of mu naught epsilon naught. This actually defines the speed of light. This is a formula, right? This formula we are going to use into the 12th chapter of 12th standard, that is named as electromagnetic waves. It is defined as electromagnetic waves. Okay, and this is nothing else but the speed of light. 1 by under root of mu naught epsilon naught, that is speed of light. In speed of light, it is defined as meter per second, having the dimensional formula m0 L1 T minus 1. m0 L1 T minus 1. The C is the perfect answer for this specific question. Okay, C is the perfect answer for this specific question. Right? Yes or no, everyone? The C is the perfect answer for this specific question. Dimensional analysis. From now, dimensional analysis starts, in which principle of homogeneity plays the important role, and many of the questions are asked into an examination from it. Principle of homogeneity in the Hindi film, right? All the best. You have seen. ढोंढू जो कल तेरा था, गीता में लिखा आज वो मेरा है, वो कल किसी और का होगा. Right? Just chill. What actually is the principle of homogeneity? In simple day-to-day life, if I want to represent the principle of homogeneity, then it is nothing else but yes or no? जो तेरा है वो मेरा है, जो तेरा है वो मेरा है, जो मेरा है वो तेरा, जो तेरा है वो मेरा है. The principle of homogeneity states that for any mathematical expression for being valid, for any mathematical expression to be valid. For any mathematical expression to be valid, right, dimensions of LHS is always equivalent to in any mathematical expression that has been used, or obviously we are going to define it, that is by use for physics. Any mathematical expression that is being used for physics, any mathematical expression that has been defined to use for physics, the dimensions on the LHS side is always equivalent to the dimensions on the RHS side. The dimensions on the LHS side is always equivalent to the dimensions on the RHS side, right? The dimensions on the LHS side is always equivalent to the dimensions of the RHS. Now, students might be having the question into your mind. So what happens when on the either side, like on the LHS or on the RHS side, if we are having more than one expression? See, on the basis of this and the three noteworthy points, all of those questions of the principle of the homogeneities can be solved. Suppose, let us take an example. If I'm talking about F is equal to M into A, I can say the dimensions on the LHS side is matching on the dimensions on the RHS side. Yes, the equation is dimensional valid and the principle of homogeneity doesn't violate. But what about, see, the most important stuff I'm talking about. Let us take the another example of the equation. S is equal to ut plus half at square. What about this expression? How we are going to define the homogeneity for this expression? Okay. Bernoulli's equation. P is equal to P0 plus rho GH plus half rho V square. How we are going to define the principle of homogeneity for this expression? For that, write a special statement that has been used. Two physical quantities can only be added or subtracted if they have same dimensions. What does this statement means? Force can be added with force. Velocity can be added with the velocity. If the two physical quantities are having the same dimensions, then they can be added or subtracted. It means that if I'm talking about this equation, S is equal to ut plus half at square, the dimensions of the half at square will be d. The dimensions of the ut will be d. The dimensions of the S will be d. Right, then the principle of the homogeneity is not going to violate. Then the principle of the homogeneity is not going to violate. Just keep this thing into your mind, everyone. Okay. So the two most important statements of the principle of the homogeneity. The first one, it states that, right, all of the dimensions on the left hand side of the expression that has been used in physics is equivalent to right hand side. If the right hand side is having more than one mathematical expression, then it states that two physical quantities can only be added or subtracted if they have the same dimensions. It means that force can be added with force, velocity can be added with the velocity, right? Everything moves on to like that. What is the question solving approach? Okay, these 2 points that we have seen into the previous season presentation slide, apart from this, the 3 most important points that we are going to use. The first point, all the trigonometric terms sine, cos are dimensionless. They are not having any kind of the dimensions, right? They are not having any kind of the dimensions. All logarithmic terms are dimensionless. All of those logarithmic terms are dimensionless. All of those logarithmic terms are dimensionless. Third, all e to the power terms sorry, using these 3 points, right, and on the previous presentation slide, this 2, the first one, the second one, right, the 3, 4 and 5, using 5 points, right? These are the question solving approach among these 5 points to explains the actual concept of the principle of the homogeneity, to explains the actual concept of the principle of the homogeneity, right? And all of those 5 are the question solving approach. Okay, and see, keep this thing into your mind. On the basis of the principle of homogeneity, yes, the questions are coming up into the NEET and JEE examination. The questions are always coming up from this into the examination. Are you all ready? Let's use this question solving approach to find the dimensions. How it is used? See, let's move on to what does the question states. The velocity v of the particle at any time t is given by this expression. See how expression the weird is. Again, I am rewriting it. V is equal to A of t plus B by t plus C. A, B, C are constants. Then the dimensions of A, B and C are. This is a mathematical expression given, right? This is the mathematical expression given. V is equal to AT plus B by T plus C dash C. Actually, it's not C dash, it is C. It states it is not violating the principle of homogeneity. It means all of those terms on the LHS, right? The dimensions on the LHS side is equivalent to the dimensions on the RHS. But. Dimensions on the LHS is equivalent to the dimensions on the RHS, right? But what happens here, on the right hand side we are having the more than one mathematical expression. So it means 2 physical quantities can only be added or subtracted if they are having same dimensions. See, we have seen in this, 2 physical quantities can only be added or subtracted if they are having the same dimensions. Same we are going to use it up here. Here, T and C, they are added as because they are having the same dimensions. T and C has dimensions, right? T and C has same dimensions, then
they are added. It means dimensions of C is equal to dimensions of T. T is time, so C is having the dimension T to the power 1, right? C is having the dimensions T to the power 1. Yes or no? So we got it. Now, suppose can I consider this as X and this entire term as Y. So can I rewrite this expression V is equal to X plus Y? X is having the same dimensions as of V. Y is having the same dimensions as of V. Then they are added. It means that dimensions of X is equal to dimensions of V. Dimensions on X is equal to dimensions on Y. Right? So to find out the A, can I say V is equal to C? This is mathematically incorrect. Logically, right? Okay, it is incorrect, but dimensionally it is valid. There is a difference what we are thinking dimensionally, right, and to the logically. Right? Logically it is invalid. Mathematically, right, it might be valid or invalid, but here dimensionally, dimensions, we are dealing with the power of the units, not its values. Mark my words, many students might be having the doubt into their mind how you can immediately cut off this part and equate V is equal to 80. No, I am dealing with the power of the units, the dimensions. So A is equal to velocity by time, it is acceleration, it is m0 L1 t minus 2. This is a dimensional formula of the acceleration. We got the C, we got the, right, now B. Again, can we write it on dimension on X is equal to dimension on Y, right? Or dimension on V is equal to dimension on Y according to the principle of homogeneity. So can I write, see now, dimensionally if I'm going to write T or C, it is going to same whether I'm going to write T or C. Generally students used to commit the mistake, they used to make it at 2T or 2C. No, dimensions of T and C are same. So dimensionally if you write T or C, it is not going to affect anything. So can I write it as B by T, that is equal to V. So B is equal to V into T. So dimensions of B, that is equal to L1. So this is a dimensional formula of A, this is a dimensional formula of B, and this is a dimensional formula of C. L1 T minus 2, L1 T. B is the perfect answer for this specific question. Right? This is how the principle of homogeneity is used. Okay, this is how the principle of the homogeneity is used. I'm moving aside on the countdown of 5 seconds or let's say 10 seconds. If you want to pause this video, you can pause it up, right? 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay. Let's move on to the next question onto it. The force of the interaction between the two atoms is given by this equation. Force of interaction between the two atoms, it is given by this equation. What is that equation? F is equal to alpha beta e to the power, right, minus x square by alpha kt. X is the distance, K is the Boltzmann constant, T is the temperature. Then what are the dimensions of beta? According to the principle of homogeneity, all of these trigonometric terms are dimensionless. All of those logarithmic terms are dimensionless. All of those e to the power terms are dimensionless. Right? Then how we are going to define this stuff? Okay, first of all, let's enjoy. Right? Giving you all 10 to 12 seconds, right, to pause this video. Okay, and solve it up. Okay? Come on everyone, on the countdown of 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All of the e to the power terms are dimensionless. So according to the principle of homogeneity, can I say this term is dimensionless? It is having no dimensions. When it is dimensionless, if x square will match alpha kt, then e to the power term will be dimensionless. If all of those dimensions of x square are matching to the dimensions of alpha kt, everything is going to get cut. Nothing is going to remain then and then, right? The E is going to be dimensionless. We are going to follow the reverse psychology, right? We are going to follow the reverse psychology. Okay. So here x is distance, L square is equal to alpha t. K is a Boltzmann's constant. It is having the dimensional formula m1 L2 t minus 2k minus 1. Temperature is T, it is having the dimensional formula K. This is going to get cancelled, right? So alpha, it is going to be, L square is also going to be get cancelled. M to the power minus 1, T to the power 2. This is the dimensional formula of alpha, right? Now, E is dimensionless. So whether it is, we are going to write dimensionally, whether we are going to keep this term or not, nothing is going to affect. So can I say F is equivalent to alpha beta? Beta is going to be equivalent to F by alpha. F is m1 L1 t minus 2, right? Whole divided by alpha is m minus 1 t of 2, right? So finally beta we are going to obtain in as beta, that is equal to m to the power 2 L to the power 1 t to the power minus 4. The B is the perfect answer for this specific question. Okay, this is how the principle of homogeneity is used on the basis of the 5 most important points. Right, on the basis of the 5 most important points, the principle of the homogeneity is used. Yes or no? Okay, let's move on to the next question on the principle of the homogeneity. A, B, C, D are the 4 different physical quantities having different dimensions. Mark my words. A, B, C, D are the 4 different physical quantities having different dimensions. None of them is a dimensionless, but we know that expression is given product of AD, that is equivalent to C ln of product of BD. This holds true, right? This holds true. Then which of the combination is not the meaningful quantity? A, B, C, D are 4 different physical quantities. None of them is a dimensionless. Are four different physical quantities, it means they are having the different dimensional formulas. None of them has the same dimensional formula. None of them has the same dimensional formula. Then which of the combination is not meaningful? See, this we are going to solve using the trial and error method. There is a possibility, that, see here in the question, dimensional formulas or the name of the physical quantities of A, B, C, D are not mentioned. There is a possibility that product of BD N being divided to C matches up to the dimensions of this term. There is a possibility. Dimensions of A square, let's say this is X. Dimensions of B square, C square. There is a possibility that dimensions of X may matches to the dimensions of Y. In another sense, let's move on to the next term. There is a possibility that dimensions of the ratio of A to B, let's say this is X, it matches to the dimensions of C to the Y. There is a possibility, because things are not defined. But this is not possible, A minus C, if A and C are different. If they both are different, then how they are added? The principle of the homogeneity is getting violated. How they are added, guys? Principle of homogeneity, it is getting violated. How it is possible? How they are added? So which of the expression is not meaningful? D violates the principle of the homogeneity, the one of the important point of the principle of the homogeneity, and hence it is not meaningful. Now we are moving forward to the dimensional analysis and its unit conversion. Right, unit conversion. Here conversion is there. There are, see, dimensional analysis. The name itself states that we are analyzing the dimensions of any physical quantity or its relevant expression. How dimensional analysis is going to help us in this stuff? How dimensional analysis is going to help in this stuff? So to begin this, we are going to start with any physical quantity it is made up of the two things. Any physical quantity, it is made up of the two things, right? The first one is a numeric value and second one it is unit. P is the physical quantity, N is numeric value, U is unit. P is a physical quantity, N is a numeric value, U is the unit. P is a physical quantity, N is a numeric value, U is it. Any physical quantity, it is made up of this two. And here, first, N is always inversely proportional to the U. The higher will be the numeric value, lower will be the unit system. The lower will be the unit value, numeric value, the higher will be the unit system. What will be the example of it? 1 kg, that will be equivalent to 1000 gram. 1 kg, right, it is equivalent to 1000 gram. This expression is generally useful, okay. Unit conversions. It is generally useful for the unit conversions, right? Yes or no? Sorry for the interruption. This expression is generally used for the unit conversion. Whenever we want to convert the the values of the one physical quantities from one unit system to another unit system, right? Then this kind of the expressions are used. Okay. Suppose let us take some examples to understand it. First, right, 1 Pascal, that is equal to how much Newton per meter square. 1 atmosphere, that is equal to how much Pascal, right? 1 Newton, that is equal to how much into the CGS units. Okay, so to convert the one unit system into the another unit system, okay, this kind of the equation, right, MP is equal to N1 U1, and that is equal to, right, another expression for this, okay, to convert from one unit system to another unit system, that is N1 U1, that is equal to N2 U2, and this is always constant. The product of N and U, that is always constant. Product of N and U is always constant. Right? Now let's say this is one of the applications of the dimensional analysis, right? Okay, one of the application of the dimensional analysis. Now what is a question solving approach into it? Nu, that is equal to always constant. This is the first part. Second, N is inversely proportional to U. The third one, using this three approach, we are going to solve all of those questions into the, right, on the basis of the one of the applications of the dimensional analysis, right? One of the applications of the dimensional analysis. So are you all ready? Yes or no? Everyone, those who are live, I means they are watching this lecture into the recorded mode. Okay, now let's solve it. Select the correct graph among all. N is a numeric value, U is unit. N is the numeric value, U is the unit. Select the correct graph among all. Okay, I've explained that expression according to the question solving approach, right? Any physical quantity, it is made up of the two things, N and U, and that is always constant in all unit systems. So can I say N U, that is equal to constant, removing the adding the proportionality sign, N is inversely proportional to U. So first, if it is N versus U graph, N versus U graph, then it is a hyperbolic kind of curve. Why? N increases, U decreases, N decreases, U increases. right? So if it is n versus u graph, second, suppose if you want to follow this equation that n is equal to constant, right, by u, then it is following y is equal to mx. This follows the equation of line, the straight line with zero intercept, right? So basis on this, on the graph basis, only two questions are coming up into the examination. One, if it is n versus u graph, it is going to be like this way. Second, if it is going to be n versus 1 by u, it is going to be straight line. These two graphs are only possible. B is the perfect answer for this specific question, right? B is the perfect answer for this specific question. Yes or no, guys? Everyone? 1 Pascal into the CGS system. CGS. Very simple explanation for it. 1 Pascal, Newton per meter square is equal to dash, right, CGS. Yes or no? Can I say this is N1? Can I say this is N2? I'm sorry. Can I say this is U1? Can I say this is N2? Can I say this is U2? Can we compare this formula? N1, U1, N2, U2. The value of U2 that is coming out from this equation, right, will be the conversion factor from one unit system to another unit system. Whatever the value of that is coming out into the N2, that is the conversion factor into the, right, into the conversion from the one unit system to the another unit system. Yes or no? That will be the conversion factor, right? In another sense, you can also write it down, 1 Newton per meter square, that is equal to 1, right? Newton, it is a kg meter per second square into meter square, that is equal to 1 into kg, right, per meter second square. If you want to convert into the CGS, 1 10 to the power 3, this will be gram, okay, meter 10 to the power 2, right? So this is gonna be second square, na? Okay, so it's gram per second square. Okay, 10 to the power 3, 1 meter below, that is 10 to the power 2, right? Okay, 10 to the power 3, so that is going to be, or you can say 1 Pascal, that is going to be 10 CGS pressure. You can use this formula also, or you can use direct conversion of it, right? You can use this formula also, and you can use the direct conversion of it. Okay, so this was one of the applications of the dimensional analysis, right? Now, how the relations are derived, how the relations are derived using the, right, this is the second applications of the dimensional right analysis. Okay, how the see, if I'm talking about the dimensional formula, then it is a very simple thing, right? The representation of the any physical quantity in terms of fundamental physical quantity, then we can say we are writing up the dimensional formula. But why this this is a second application of dimensional analysis? First of all, Second application of the dimensional analysis, I must say, right, in which if we want to represent any physical quantity in terms of derived, this helps us in deriving the dimensional formula of any physical quantity in terms of not fundamental physical quantity but the derived one. I'm sorry for this. Today my voice appears to be quite different, right? Because recently I went on the outing, and as of the sudden weather changes, it happened like that way. Okay, and lots of snorkeling and everything that I did. Finally, I'm here. Right. The second applications of the dimensional analysis. Suppose the dimensional formula of the force is m1 l1 t minus 2. The force we have represented in terms of the fundamental physical quantities. But I want to ask you all, suppose if I want to represent mass in terms of force, in terms of velocity, in terms of energy. This second application is used of the dimensional analysis. The representation of any physical quantity in terms of the derived one. How mass depends on force, energy and velocity. Suppose if I want to represent the time, or let's say velocity, right, or in terms of, okay, force, energy and momentum. Suppose if I want to represent the time is direct having the relation, right, with energy, right, angular momentum and force. How we are going to define that stuff? This is a new thing, no? And this kind of the questions are also coming up into an examination all the time. Okay, this kind of the questions are also coming up into the examination all of those time, right? So this is the second application of the dimensional analysis, and it is having the simple question solving approach, right? It is having a simple question solving approach. First, steps. Write down the dimensional formulas on the either side. Write down the dimensional formulas on either side. First, and the LHS side, write down the dimensional formula. On the RHS side, write down the obtain mathematical expression from it. Obtain the mathematical expression from it. Evaluate and reach up to final results. Evaluate and reach up to the final result. These are the steps, right? Don't get worried. The steps we are going to, the same steps we are going to use for all of those sums, right? Okay. Shall we begin? This three, right, important thing. The dimensional formula of the critical velocity of the liquid. Dimensions of the critical velocity of the liquid falling through the tube depends on eta, rho, radius. Eta is coefficient of viscosity, rho is density of liquid, r is the radius of tube. Velocity is directly depend on coefficient of viscosity to the power x, density to the power y, radius to the power z. then they are saying what is the value of x, y, z. To find the value of x, y and z, first of all we need to obtain the dimensional formula, or first of all we need to obtain the expression of dependency of velocity on these three physical quantities. Anyone the coefficient of viscosity formula we are not aware of. F is equal to eta del v by del x, right? Okay. So from this also, right, you can obtain the the formula, the dimensional formula of the coefficient of viscosity, right? Generally, these students are not aware. Okay, write down. I'm directly taking it as. Okay, so what is the first step? Okay, to evaluate all of those terms, right, and write down the dimensional formula. Okay, see, on the left side, dimensional formula of the velocity is L1t minus 1 is directly proportional to what is the dimensional formula of coefficient of viscosity? M1 L minus 1 t minus 1 to the power x. Okay, what is the dimensional formula of density? Mass per unit volume. M, mass per unit volume, m to the power 1 L to the power minus 3. Y, what is the radius? L to the power 1 Z. Step 1, write down the dimensional formula on the either side. Step 2, obtain the mathematical expression for it. Comparing the terms on the LHS side and the RHS side, L1 t minus 1 is directly proportional to m to the power x, L to the power x, minus x, t to the power minus x, m to the power y, L to the power minus 3y, L to the power z. Combining all of those terms, if I'm combining m to m, I'm getting m to the power x plus y. If I'm combining L, right, then it is L and L, it is minus x minus 3y plus z. T, it is only minus x. It's directly proportional to L to the power 1, t to the power minus 1. Now we want to obtain the mathematical expressions for it, right? Now this equation, if it is given, then it is dimensionally valid. It is dimensionally valid. So the powers on the LHS side, that is equivalent to the powers on the RHS side. Right, so if I'm comparing the t term, minus 1 is equal to minus x, value of the x we are going to get it as 1. If we are comparing m side, here m is not there, m is 0. So can we say that 0 is equal to x plus y, right? X is equal to minus y is equal to minus 1. We got the value of y. Now, comparing the dimensions, the powers of L, third, right? Can we say 1, that is equal to minus x minus 3y plus z. What is the value of x? Minus 1. What is the value of plus 3 plus z? Z, you are going to get it as minus 1. Right? So what does the formula we obtain? We obtain the dimensional formula of the dependency of the velocity on the another physical quantities, right? Like V is directly proportional to eta to the power 1, density to the power minus 1 and R to the power minus 1. This is a perfect answer for this specific question. This is how the relations are obtained, and the same procedure we need to follow. Obtain the mathematical expression, we evaluated and reach up to the final results. So these are the 3 steps we need to follow, right, in solving the questions, right, basing on this dependency. Yes or no? Let's move on to the next question onto it. Momentum, area and time are taken to be the fundamental quantities. Then what is the dimensional formula of energy? energy is directly depending on momentum, area, time. P is a momentum, A is an area, T is an time. Step 1. Write down all of those dimensional formulas on the either side. Dimensional formula of energy is M1 L2 T minus 2 is directly proportional to. Dimensional formula of momentum M1 L1 T minus 1 whole to the power A. Dimensional formula of area L to the power 2 B. Dimensional formula of time T to the power 1 C. Step 1 successfully completed. We wrote it down, all of those dimensional formulas on the either side. So it's m to the power 1, L to the power 2, T to the power minus 2 is directly proportional to. Can we write m to the power A, L to the power A, T to the power minus A? L to the power 2B, T to the power C. Combining the terms, right, we are getting m to the power A, L to the power A plus 2B, T to the power minus A plus C. And here M1 L2 T minus 2. Comparing the terms on the LHS and the RHS side, right? Comparing the terms on the LHS and the RHS side, what we are getting? If I'm comparing M, then I'm going to get A value as 1. Right? If I'm going to compare, okay, T minus A plus C, that is equal to minus 2. A is equal to 1. C is equal to minus 1. Finally, comparing the dimensions of L, A plus 2B, right, that is equal to 2. A value is 1, 2B is equal to 2. B you're going to get it is half. So the expression, final expression is energy is directly proportional to momentum to the power 1, area to the power half, T to the power minus 1. C is the perfect answer for this specific question. This is how things are resolved, right? This is how the things are resolved. Are you getting my point or not? Okay, are you getting my point? Yes or no? If force, acceleration and the time are chosen as the fundamental physical quantities, find the dimensions of energy, right? Energy depends on force A, acceleration B, here A stands for acceleration, time for C. Then what will be the dimensional formula of the energy into the terms of the derived one, or if they are considered as a fundamental physical quantity? Step 1. Dimensional formula of force M1 L1 T minus 2. Area L to the power 2, right? T to the power C. Right. So comparing M1 L2 T minus 2, M to the power A, L to the power A, T to the power minus 2A, L to the power 2B, T to the power C. Array. A is acceleration. See, the same mistake we did. Here the A is acceleration, right? So it's L to the power B, T to the power minus 2B and T to the power C. This is a perfect equation. A is an acceleration. Sorry, I took it as an area. Right. So it is m to the power a. L if we are combining L to the power a plus b. T if we are combining minus 2c minus 2b plus c. And it is equivalent to m1 L2 T minus 2. Can we compare the terms on the LHS and RHS side to obtain the equation? Can we compare on the terms on the LHS and the RHS side to obtain the equations? Yes or no? Comparing the terms of m, we are going to get the value of a as 1. Comparing the terms of L, a plus b is equal to 2. 1 plus b is equal to 2. B is also going to be 1. Comparing the terms of t, minus 2 is equal to minus 2c minus 2b plus c. Minus 2 is equal to minus 2c minus, here it is a, right? It's okay. 2a, 2b plus c, minus 2, minus 2, minus 2 plus c. C is going to be 2. So what is the final result that we are getting? Energy is directly proportional to force to the power 1, right? Acceleration to the power 1, time to the power 2. This is the perfect answer for this specific question. Okay, this is how things are getting resolved. I'm moving aside on the countdown of 10 seconds. If you want to move on, you can. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. That's it. This question is homework from my side. Right. The homework based question, I want you all to write down the answers beneath the video. Right, into the comment box. If you like this video, kindly have a likes for it. Okay, and beneath the video, I must say to everyone, right, write it down beneath the video the answer of this homework based question. Speed V, area A and force F are chosen as the fundamental units, then the dimensions of the Young's modulus will be what? Let's move on to the new concept. Right now in this chapter, only 2 concepts are remaining. The first one, that is a concept of errors, right? And the second, that is a concept of the measuring instruments, that is Vernier caliper and the micrometer screw gauge. Vernier caliper and the micrometer screw gauge. Now let's move on to the new concept of errors. Let's move on to the actual concept of errors. Galti. दिल गलती कर बैठा है, गलती कर बैठा है दिल, दिल गलती कर सोच हमारा क्या होगा. Okay, errors. See, errors are simply defined. Okay, it is a very errors are the what we can say the very easy concept, right, to understand, and it is completely based on 4 to 5 formulas. Right. Okay. First of all, there are right many types of questions, right, coming up into an examination. Errors is all about things happen while conducting an experiment. Things that happen while conducting an experiment. Things that happen while being in a relationship. Things that happen after a marriage. Sorry, a marriage. No, after marriage. Sorry, I'm confused. I'm still confused at what actual an error is. Okay. Things happen while, right, conducting an experiment. Are we getting the exact values of what physical quantity that we were measuring through an experiment? How much? See, lots of questions that are coming up into our mind, and basis on that we are going to define the errors. Are we getting the exact values, true values of physical quantity that we are measuring are we getting the true value of the physical quantities that we are actually measuring? How many observations we took? How many physical quantities are involved in an experiment? All of this thing is going to define the error. This all lots of factors are there. How environmental conditions plays an important role while moving on for an experiment, right? How instruments are supporting you all, right? Are we getting the exact value of what the actual, right, the physical quantity that you all are measuring? If we are not getting an exact value, then what is the difference between the value that you have measured and the true one? Suppose if you are conducting an experiment to measure the gravitational acceleration of the earth, you are getting the value as 9.7, and what actual the value is 9.8. What is the difference? 0.1. Then that is an error. Now you are going to analyze why it arised, what is the actual reason behind it. Is there any kind of the instrumental error? Are we on the right different locations of the earth, so as because of that the value of the G is getting deferred? Lots of things are there, right? So these are the some of the most noteworthy points, right, that things happen while conducting an experiment. Depending on this, lots of theoretical errors are defined, like systematic errors are there, random errors are there, instrumental errors are there, and lots of, but those are all of the theoretical part that you can immediately see into a, right, all of those into like 3 to 4, right, or you can say the half of a page of the, right, content is written into the specific book. We can analyze it here. Another question: is it possible to measure the quantity more than once? Are we measuring a red physical quantity only once in an experiment? Ways to correct your output. This will define the error. And what is an actual, a basic definition of error? Difference between true value and measured value. Difference between the true value and the measured value. As I told you, I'll given you the example of the gravitational acceleration of the earth. G is equal to 9.8. We are getting the value as G is equal to 9.7. The true value is 9.8. The measured value we are getting it is 9.7. The difference is an error. The error can arise of any external conditions, as of the internal conditions, as of the any random errors and the instrumental errors or the personal errors. Anything can happen and it may result into getting the wrong measured value. Absolute error. There are kind of error. First of all, I'm going to define the absolute error. The absolute error and the example. Difference between the true value and the measured value. That symbolically it is defined as delta A. Right, true value minus measured value. That is defined as the absolute error. Let us move on to the very simple example to understand this concept. Okay, understand the concept of the absolute error. My father gave me the pocket money of 10 rupees. That's not possible, sir. How? In 10 rupees only, right? You are getting the lots of amount of stuff. That's not possible. Sir, please speak into your original voice. Okay, so I must say, Dad gave me 100 rupees, right, for a pocket money to buy something, whatever we want. Pocket money, it means whatever I want to do, I can. Okay, but the dad's, when he was analyzing the final expenses at the end of the month, it was showing in the system that dad gave me 110 rupees. The actual amount I received was 100, but in the system, when he measured, my dad conducted an experiment to measure the overall expenses of my child at the end of the month. He gave me the true value 100 rupees. The system was measuring the error. System was measuring the value and the final output while conducting an experiment. My father got it as 1110. What is the difference? The difference between the measured value and the true value is of 10 rupees. Plus my dignity. My dignity. How it is possible, sir? How dad gave me 10 rupees more? That is not possible. Absolute error can be positive, can be negative, can be zero. Dad gave me 100 rupees. System was showing 1110. Delta A, true value 100. System measured value 1110. Negative error. Dad gave me 100. System was showing 100. No absolute error. Dad gave me 100. System was showing 90. Positive absolute error. Absolute error, if it is calculated individually, then it can be positive, it can be negative, it can be zero. But when absolute error is calculated and the final percentages are evaluated, then errors are always positive. This is a note that you have to keep up in your mind, right? This is a note that you all have to keep up into your mind. Right? So this is a concept of the absolute error, the difference between the actual value and the measured value. Relative error. The fraction of absolute error to true value. The same example we are going to take. My dad gave me 100 rupees, but in the system it was showing, right, 110. The absolute error is 10. The absolute error, what 10 we are getting, is what fractional part of true value? Absolute error is 10. True value is 100. This absolute error is what fractional part of the true value? 1/10, 10%. Delta A, absolute error is what fractional part of the true value that defines the relative error. that defines the relative error. When relative error is calculated, delta A is always positive. And percentage errors are calculated, and if we are having more than one observations, right, okay, then these things are always positive, right? Errors are always added. The third concept is of the percentage error. When the relative error gets multiplied with the 100, we are going to get the error in percentage. My father gave me 100 rupees, the system was showing the 110. The absolute error is 10, of the true value is 100. The relative error is going to come upon as 0.1, and when it is multiplied by 100, 10% error is there. Let's see some sums based on it, and after that we are going to see. Okay, this was the details regarding an experiment in which only one, see, there is a classification. We are conducting an experiment in which, right, only one physical quantity is measured and multiple observations we are taking. Only one physical quantity is measured and n number of the observations we are taking. After that, that comes an experiment in which more than two physical quantities or more than one physical quantities are involved. And comes the classification. They are added, they are subtracted, they are multiplied, they are divided, and one quantity is repeated n times. Then how we are getting up to the results. So first of all, we are going to see one or two sums based on that, and after that directly we are going to jump on to the an experiment, the errors in an experiment in which, right, two physical quantities are added, subtracted, divided, multiplied, and the n times. I'm sorry for that. Right? In an experiment, while measuring the physical quantity, observations we got as 1.1, 1.2, 1.3, 1.4, 1.5. Percentage error into the experiment, right, will be what? Okay, just keep this thing into your mind. Okay. Number of observation is equal to number of absolute errors. Number of observations that is equivalent to number of absolute errors. Right? Number of observation that is equivalent to number of the absolute errors. Okay. 5 observations are there, it means 5 absolute errors are there, but we are not having the true value. How we are going to opt out the absolute errors rather than, right, we are not having the true value. So in that case, if we are having the more number of the observations, the mean in n number of observations, average value is true value. What is the average value of it? As I see, it is a bar 1.1, 1.2, 1.3, 1.4, 1.5 whole divided by 5. The average value it is coming up upon as 1.3. So this will be my true value. Right? This will be my true value. 5 observations, 5 errors. Delta A1. True value minus measured value, that is 0.2. Second absolute error 1.3 minus 1.2, 0.1. Third absolute error 1.3 minus 1.3, positive error 0. 1.3 minus 1.4, negative of 0.1. Delta of 5, that is equal to, right, 1.3 minus 1.5, negative of 0.2. right? But when individual errors are calculated, the absolute errors can be positive, can be negative, can be zero. But when we are evaluating the percentage errors, things are nullified and all errors are positive. But still, like we were having 5 observations, we were not aware of the true value. So we did the mean and reach up to the true value. Similarly, we are having the 5 absolute errors, but we are not aware of what actual the absolute error is. So for that reason, again, we need to opt out the mean value. 0.2, 0.2, 0.1, 0.1 plus 0 whole divided by 5. So delta A bar, it is going to come upon as 0.12. Okay, it is going to come upon as 0.12. Finally, what is the relative error? We need to calculate. Relative error is delta A bar by A bar 0.12 by 1.3. And when it is multiplied by percentage, A 0 into 100, right? Then it is 0.112 whole divided by 1.3. Approximately 9% we are getting as the answer. So we are having the 9% of error in this experiment. In this experiment, we are having 9% of the errors. I'm moving aside on the countdown of 10 seconds. If you want to pause the video and note this stuff, okay, you can. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Student measured in experiment the diameter of the pencil using the Vernier scale. We are not interested, I haven't discussed the Vernier scale right now, but we are only interested into the observations. These are the observations. Average value is this and the standard deviation is this, right? Then average diameter of the pencil. This is the homework from my side. This is a very simple sum you can do by your own. Till now, 2 homework questions I have given and I want answers by each and everyone beneath the video. Guys, please be serious, right? This victory batch is for you all. Okay, it is going to be it is going to end before the Independence Day, right? It is going to end before the Independence Day. Okay, so this is homework for you all. Combination of errors. We are conducting an experiment in which more than one physical quantity is involved. More than one physical quantity is involved. Suppose I am conducting an experiment Z I need to measure in which A and B are the quantities involved. Z is a physical quantity that I want to measure the value through an experiment, and A and the B are the physical quantities they are involved. Now here comes the possibility how they are involved. What is an actual relation between them? First, they can be added or subtracted. They can be added or subtracted. I am conducting an experiment in which I am measuring a physical quantity Z that is made up of the 2 physical quantities that are added, A and B. So in which, how we are going to write up the results? The absolute error is the summation of the individual absolute errors. The absolute error if it is added or subtracted. Whether it is added or it is subtracted, the absolute errors are going to get added. First, if z is equal to a plus b, then relative error is like delta a plus delta b whole divided by a plus b. If z is equal to a minus b, then delta z by z is equal to delta a plus delta b whole divided by a minus b. Right? Second, they are multiplied or divided. They are multiplied or divided. And guys, my each of every practice sheet is going to have minimum 30 number of the questions, right? In mechanics we will have more than 30 questions, right? So DPP on the regular basis, right? Whenever the lectures, see my lectures are coming twice in a week. Whenever they are coming, the DPPs will be provided. Okay, the DPPs will be provided, right? Yes or no? Suppose if z that is equal to a multiplied by b and z that is equal to a divided by b. So here whatever the absolute errors they are coming out, right? Whatever the absolute errors they are coming out, then we can say it is delta z by z that is equal to delta a by a plus delta b by b. This is the equation of the relative error. If you want absolute error, then it will be delta a by a plus delta b by b whole into z. Or if it is the two physical quantities are multiplied, then it is a into b. If they are, this is the first case. In second case, if they are getting divided, then it is a by b. This is how when the errors are evaluated when the two physical quantities are subtracted or multiplied or divided. What about the physical quantity? See, same physical quantity is measured n times. Z is equal to a to the power n. Directly we are going to write it up, z by z is equal to n delta a by a. Right? If n value is given as positive, right? Here I am writing down. If n is negative, then while calculating the percentage error, it is always positive, right? This is the third of the combination of error. I'm moving aside. If you want to just write it down on the countdown of 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Let's see some of the sums based on it. Right. The dimensional formula of the any physical quantity is m to the power, see, dimensional formula of any physical quantity is m to the power -1, L to the power 3, T to the power -2. The percentage error in measuring the M and LT are 2, 3 and 4. What is the maximum percentage error that occurs in quantity X? I told you all, here we are conducting an experiment in which X is measured. It involves the three physical quantity M, L, T. M is having the dimensions of -1, L is having the dimensions of 3, T is having the dimensions of -2. In spite of N value being negative, we have to consider all of as positive. So here, if I am writing down if the equation, see here, it is a combination of the two cases. First, one physical quantity is multiplied n times. Like this, three quantities are multiplied together. So it is a combination of two cases. So I'm going to write it upon as delta x by x, that is equal to 1 delta m by m plus 3 delta L by L plus 2 delta T by T. Please don't commit a mistake writing -2 here. Okay. Errors are always positive while you are calculating the percentage part. Multiplying 100 on both sides. Multiplying 100 on both sides. You are going to get percentage error in X. What is the percentage error in M? 2, L 3. Okay. So it is 1 into percentage error 2 plus 3 into 3 plus 2 into 4. So this is 2 plus 6 plus 8. Total 16% of error came up into the experiment. Right? One, twos are, 3 threes are, I'm sorry, 3 threes are 9. See, this is how things are going on. %19 of error is there. Right? D is the perfect answer for this specific question. This happens. 3 into 3, 6. Right? Okay, 19% of error is there. 19% of error is there. So this is the first question based on the combination of error. Generally, this kind of the questions are asked right into an examination and always there. Right? So this chapter is a quite scoring one. While two resistors, see, if two resistors are connected in series, then question is going to be quite easy. But when the two resistors are connected in parallel, things may differ. While two resistors are connected in parallel, calculate the equivalent resistance of it. What is the formula of the equivalent resistance when they are connected in parallel? This logic is applicable for three kind of the question. First, resistors in parallel. Second, mirror formula, 1 by V, 1 by U. Right? Sorry. Or lens formula. Third, it is applicable to the capacitor. They are connected in series. Resistors in series. Mirror formula. Capacitors in series. Resistors in parallel. Sorry. This kind of the logic is applicable to these three formulas. Now, among them, we are going to solve the first one. Okay, suppose if I am writing down the equation, I am going to get the equivalent resistance, that is equal to R1 R2 whole divided by R1 plus R of 2. Here three physical quantities are involved. One is R1, second is R2. Can I write it as R1 R2 whole divided by R of 3, where R of 3, that is equal to R1 plus R2. Then things will be quite easy. So what we are going to get? Delta R equivalent whole divided by R equivalent. that is delta R1 by R1 plus delta R2 by R2 plus delta R3 by R3. Now we are going to replace the exact equation. Okay, so delta R equivalent by R of equivalent, that is equivalent to delta R1 by R1 plus delta R2 by R2, right, plus delta R1 plus delta R2 whole divided by R1 plus R of 2. I replace this again. So whenever they are connected in the parallel, this is an exact formula that we need to use. This is the exact formula that we need to use. Yes or no, guys? This is the exact formula that we need to use it up. Okay. So here delta R by R, that is, what is the value of delta R1? 0.03 whole divided by 4 plus what is of R2? 0.01 whole divided by 3 plus 0.03, 0.01 whole divided by 7. Okay, so here what we are getting, delta R, right, by R, that is equivalent to 0.03 whole divided by 4 plus 0.01 whole divided by 3, 0.04 whole divided by 7. Right, now we need to evaluate this to reach up to the result. Right, so on evaluating the result, the absolute error you are going to come upon as 0.01 whole divided by 3, 0.04 whole divided by 7 into R1 R2 whole divided by R1 plus R2. So replacing the values, because here R will be shifted on that side to calculate the right actual error. So delta R you are going to get is 0.028. Okay, 0.028 you are getting. So final equation is R plus or minus delta R. So this is R1 R2, that is 12 by 7, right, plus or minus 0.028. Finally it is going to come upon 1.71, 0.028. This will be the equivalent resistance of the two resistors connected in parallel. The equivalent resistance of the two resistors, those are connected in parallel. Right or wrong? The equivalent resistance of the two resistors, those who are connected in parallel. Right? Let's move on to the next question onto it. The physical quantity is having the described by the relation P, that is equal to A to the power half, B to the power square, C to the power 3, D to the power minus 4. If the relative errors into the measurement of A, B, C, D are 2, 1, 3, 5, relative error in P will be what? Actually here it should be percentage error. Percentage error in P, that is equal to half delta A by A plus 2 delta B by B plus 3 delta C by C plus 4 delta D by D. 2, 1, 3, 5. 2, 1, 3, 5. 2 is going to get cancelled. 1 plus 2 plus 9 plus 20. 3 plus 29. 32% of error it is coming out. C is the perfect answer. C is the perfect answer for this specific question. Right? So this kind of the questions are coming up from the combination of the errors. Right? Again, the third question, you have to do by it yourself. I'm going to show you all. Homework. Right, so the three questions are given you all the homework. Now in this chapter only two concepts are remaining. The first one, that is a Vernier caliper, and the second, that is a micrometer screw gauge. The first one, that is a Vernier caliper, and second is a micrometer screw gauge. Right, so guys, the three questions are given you all into the homework, and I want all of your right to answers beneath the video. And please do support this, right, because all of those VFX and the 3D content that what I've kept into the beginning of the video, that is for you all. That is for you all, right? That is for you all. Okay, so please support this video, right? by sharing it maximum to all of those students, those who are waiting for the content into the pure English mode. I want this video to reach up to those, right, all of those students, and you can only help us, right, by sharing it maximum on your social medias, right, by sharing it maximum on your social medias. Now let's move on to the last concept of this chapter, that is measuring instrument, in which calipers. Why Vernier caliper? Caliper and micrometer screw gauge are simply based on three formulas. 3 of the micrometer screw gauge, 3 of the Vernier caliper. Why Vernier caliper? If I'm talking about our day-to-day life, if I'm talking about daily day life, then for the measurements, we are using meter scales, right? We are using meter scales like this. Starts from 0. Meter scales we are using. The meter scale is having the capability to measure 1.2 centimeter, 1.3 centimeter, 1.4 centimeter. The scale has capability to do this. What about the values, right, that we want to measure into the day-to-day life and that exceeds the 1 decimal place? Meter scale can't measure 1.52, 2 decimal places, 1.64, 2 decimal places, 1.643, 3 decimal places, 1.824. Meter scale can't measure this. Entire physics depends on, I told you all, why and suppose. If there is why, there is a suppose. If we are reading something, if we are understanding a concept, then there should be the logic behind it. Why this is happening. If we are analyzing any activity, then we are up to right onto the logic behind it, why it's happening. Meter scale can't measure up to 2 or 3 decimal places, see, right? So the reason of introducing the Vernier caliper and micrometer screw gauge is to measure the values up to 2, 3. More decimal, 4, 5, 6, 7 decimal places you can measure out, right? But on increasing the decimal places, the number of these significant digits are getting less. You will get the less accurate value. Generally, it can measure up to more, but up to 2, 3, okay, 4 decimal places, things are gonna be all right. Up to 2, 3, 4 decimal places, things are gonna be all right. Right. So this was the purpose of introducing the Vernier caliper. Right. Like this, the same purpose the micrometer screw gauge holds, to measure the value, more accurate values up to the 2 or 3 decimal places. Vernier caliper is having a specific construction that we are going to discuss it right now. Basically, Vernier caliper is having 2 types of scales. This is the main scale of Vernier caliper. The main scale. Above this, right, we are having the another scale, that is the Vernier scale is a movable scale, right? Vernier scale is a movable scale. The main scale is the fixed scale. Upper one is a movable scale. The lower one is a fixed scale. The divisions on the main scale are the main scale divisions. The divisions on the Vernier scale, right, are Vernier scale division. Right. These are VSD, right, and this one, right, is MSD. MSD stands for Mahendra Singh Dhoni and VSD stands for MSD stands for, right, main scale divisions, and VSD stands for Vernier scale divisions. Vernier caliper, it is having the three applications: to measure the internal diameter, to measure the external diameter, and to measure the length. There is one part attached to it, okay, that measures the length of the cylinder or any object. Hollow cylinder. Attached to this, we are having two jaws. Right? Attached to this, we are having the two jaws. Now, what kind of these two jaws? The first one, that is an upper jaw to measure the internal diameter. Like this way, we are having two jaws. Okay, this is known as upper jaw. Jaw itself states that panja, to grab out something. Beneath this, right, we are having, okay, the lower jaws. The upper jaws, the lower jaws. Upper jaws are to measure the internal diameter. Like this way, cylinder is kept, right, and things are attached. We are having one screw here. Okay, this screw will adjust the Vernier scale and it grabs the jaw. This is to measure the external diameter. So these are the, right, external dia, right, internal dia. External dia, internal dia, main scale, Vernier scale, length of this cylinder, screw, upper jaws and lower jaws. This is what an actual construction of the Vernier caliper is on. The actual construction of Vernier caliper. Sorry, I didn't introduce the figure because I can understand this figure is quite weird, but it will be helpful to understanding the concepts of the Vernier caliper. It will be quite helpful in understanding the concepts of the Vernier caliper. Yes or no? Okay, now let's move on to the next part onto it. Least count. Least count is the minimum value that can be measured on the instrument by eyes. Minimum value. Minimum value on an instrument by an eye. Sir, it is very easy. In Vernier caliper, right, the Vernier scale division is a minimum value. Nakko. Sir, I think the main scale would be the minimum value. Nakko. This is a main scale, and above it we are having the Vernier scale. Suppose this is the one division of the Vernier scale. Okay, and this is one division of the main scale. This is 1 MSD. This is 1 VSD. 1 MSD is not a minimum value that we can see by an eyes on the caliper. No. 1 VSD is not a smallest value. I must not say minimum value. I must say it is a smallest value. Okay. 1 VSD is not the smallest value that can be seen on an instrument by an eye. No. This is 1 MSD. This is 1 VSD. Right, I'm extremely sorry for that. I hold it on, please. Sorry for the interruption. Right, calls from the companies are going to come. So, the 1 MSD is the higher 1 MSD as compared to the 1 VSD. 1 MSD is having the more width. So 1 MSD minus 1 VSD, the difference that what we are getting is the smallest value we can measure on an instrument, and that is the least count. 1 MSD is the one division on the main scale. 1 VSD is the one division on the Vernier scale. The difference between these two is the minimum value that we can see on the scales. Right? Not minimum, the smallest value, and that is the least count. So this is the formula of the least count, and this is the actual definition. Basis on this, let's evaluate one sum. The main scale of the Vernier caliper has n divisions per centimeter. N divisions of Vernier scale coincides with n minus 1 divisions on the main scale. What it is written? N Vernier scale divisions that coincides with n minus 1 of main scale divisions. N Vernier scale divisions that coincides with n minus 1 of the main scale divisions. The least count will be what? See, we are aware of the formula of the least count. One thing I want to remind you all, and I want you all to make a note of it. The another name of the least count is Vernier constant, because in some of the questions the Vernier constant word is also used. So here let's make 1 VSD as a subject, that is equal to n minus 1 by n of MSD. Can I consider this as equation number 1? Can I consider this as equation number 1? Yes or no? Yes. Now what is an actual formula of the least count? Least count, that is equal to 1 MSD minus 1 VS of D. Right? So this is 1 MSD, right, minus n minus 1 by n of VSD. So this is going to come, sorry, not VSD, MSD. So it is going to be 1 by n of MSD. Least count, we are getting it as 1 by n of MSD. But we need answer in centimeter. One main scale division has n divisions in 1 centimeter. In 1 centimeter, one main scale has n divisions. So can I say 1 MSD is equal to n divisions per centimeter? Replacing here, we are going to get the least count as 1 by n square centimeter. The C is the perfect answer for this specific question. C is the perfect answer for this specific question. A Vernier caliper has 1 mm marks on the main scale. 1 mm mark on the one scale, it means one main scale division, it is of 1 mm. 20 equal divisions on Vernier scale, which matches 50 divisions on main scale. 20 on Vernier scale acquires the same space as compared to 15 on main scale. It means 20 VSD is equal to 15 MSD. See, Vernier constant, a new word come upon. It is used. 1 VSD, you are going to get it as 15 by 20 of MSD. That is equal to 3 by 4 of MSD. What is the formula of the least count? That is equal to 1 MSD minus 1 of VSD. So that is 1 minus 3 by 4 of MSD. It is 1 by 4 of MSD. Now one main scale division is of 1 mm, right? So least count, it is going to come upon as 0.25 mm. B is the perfect answer for this specific question. B is the perfect answer for this specific question. Here comes the another concept of the zero error. It's a very simple. Three kind of the formula of the zero error is quite. First of all, what is a zero error? When, see, these two words are used. When two jaws touch together or no object is kept. When two jaws are touched together or no object is kept. With no object is kept or two jaws are touched together, right? Then if error arises into the instrument, then it is known as the zero error. If error arises into the instrument, then it is known as the zero error. Right? Sorry for interruption. Three kind of the zero error exist, right? When both jaws touch together, what is the position of the Vernier scale and main scale? Three possibilities may arise. The zero of the Vernier scale is exactly coinciding with the main scale. The zero of the Vernier scale is ahead of the main scale. The zero of the Vernier scale is behind the main scale. Strictly, I am telling you, this word will be used. No object is kept. The formula of the zero error is nth division coinciding into least count. Nth division coinciding into the least count. Right? Now what is this nth division coinciding? When object is not kept. Basically, we are having the three types of the zero error. See, this is a Vernier scale and this is a main scale. When zero of the Vernier scale exactly coincides with the zero of the Vernier scale, right, then we are having the zero error. When Vernier scale, the zero of Vernier scale is ahead of main scale, then we are having the positive zero error. In which, how to calculate the value of n? Which division is exactly coinciding? See here. This is the value of n, 3. The n is equal to 3 is exactly coinciding between the Vernier scale and the main scale. Similarly, in this, zero of the, I'm sorry, here the zero of the Vernier scale is behind the main scale. Here the zero of the Vernier scale is right ahead of the main scale. I'm sorry. Exactly division coinciding is 8. In this case, case number 2, case number 3, zero error is equal to n into least count. It is a positive zero error. Number of the division, the nth division coinciding is 3. Let's say least count is 0.1. We are going to get 0.3 as the zero error and it is positive. I have taken the value of the least count as 0.1. In the third case, n into the least count, but we are having the negative error, right? So it is 8 into 0.1 is equal to 0.8 of negative error. This is how zero error is calculated. If zero of the Vernier scale is behind the main scale, we are having positive error. If zero of the Vernier scale is above the main scale, we are having the negative error. Right? Let's evaluate some based on it. Find the zero error into the system. Find the zero error into the system. Okay, let's say this is the main scale. This is a Vernier scale. The above is the main scale, below is a Vernier scale. See, zero of the Vernier scale is beyond. Zero of the Vernier scale is beyond the main scale. Check it out. Zero of the Vernier scale is beyond the main scale. We are having the positive error. In this case, we are having the positive zero error. Zero of the Vernier scale is beyond, positive zero error. In this case, we are having the negative zero error. What is the formula of the zero error? Nth division coinciding into the least count. Check it out, which division is exactly coinciding? Fourth. In this case, fourth division is exactly coinciding. Right? In this, ninth division is exactly coinciding. And in this, seventh division is exactly coinciding. So here, zero error, we are going to get it as 4. Least count is given as 0.5. 2 mm is of zero error. Positive. Here, n into least count. N is 9, least count is 0.5. Positive 4.5 mm of zero error we are going to get. And here n is 7 exactly coinciding. N into least count, that is 7 into 0.5, right? So that is 3.5 negative. This is the actual concept of the zero error. In Vernier caliper, it is calculated into the different way, while into the screw gauge, it is calculated into the else way. What is the formula of the actual reading? How many scales are there? 2 scales. It means we are having the 2 readings. So, the actual reading is having the formula that is main scale reading plus Vernier scale reading minus zero error. If zero error is positive, then it is going to subtract from this value. If zero error is negative, then it is going to add up into this value. Generally, anyone who explains this kind of the concept, they used to have this statement. But I am telling you all, please don't get into the mess. You should be clear. Zero of the Vernier scale above, zero of the Vernier scale beyond, positive, negative, this kind of thing you should remember. Else, the calculate completely, it will depend on the calculations. So this is the formula, right? And we are going to solve sums based on it. Diameter of the steel ball is measured into the Vernier caliper, which has 0.1 centimeter on its main scales. Right. First of all, I want to tell you all 1 MSD. It is given as 0.1 centimeter. 10 divisions of Vernier scale matches 10 VSD matches 9 MSD. Immediately we are calculating the least count 1 MSD minus 1 VSD, right? So it is equal to 1 minus 9 by 10 of MSD, right? So it is equal to 0.1 of MSD, and MSD is of 0.1 centimeter. So it is 0.01 of centimeter. This will be the least count. On basis of data, we evaluated the least count. He did 3 measurements. The first main scale reading was this, and Vernier scale division coinciding was this. Right? Now here, zero error, negative it is given. Right? Negative zero error it is given. It means it is going to add up into the main value. Main scale readings are fixed 0.5. In first, right, eighth division was coinciding when this is when object is kept. This is not zero error when object is kept. Right. In first, it was 8th division coinciding in second, 4th, 3rd, 6th. Least count is 0.01 centimeter. Main scale reading, it is 0.5 centimeter. 4th, 8, 4, 6, 0 error. That is negative of 0.0, I'm sorry, 3 centimeter. First, let's apply the formula. Actual reading is main scale reading plus VSR, right, minus 0 error. This is actual reading A1. Main scale reading is 0.5. Let's just check it out. It's 0.5 centimeter. Yes, it's centimeter. Plus VSR. Nth division first is 8. Right. Into the least count is 0.01. Okay. Plus 0.03. Zero error is negative. So it is going to add up into the actual value. This is A1. A2. 0.5 plus 4. 4 into 0.01 plus 0.03. And A3 is going to be 0.05 plus 4 into, 6 into 0.01 plus 0.03. 3 readings we are having. What will be the actual reading? The mean of all. A1 plus A2 plus A3 whole divided by 3. Okay, if you don't want, see, you are going to calculate the value of A1, you are going to calculate the value of A2. Let's say this is gonna be 0.5 plus 0.08, okay, plus 0.03. So this is gonna be 0.5, 0.08, 0.03, 0.5, A3, 11, 6, 0.61. This is gonna be, the first value is gonna be 0.61. Right? The first value is gonna be 0.61. The second value is gonna be 0.57. Right? It is 0.04 plus 0.03 is 0.07 plus 0.5, it is 0.57. The third value is gonna be 0.59. So average we are going to opt it out, 0.57 plus, right, 0.61 plus 0.59 whole divided by 3. Nearly answer it is going to come upon as 0.59 centimeter. Right, this is an actual, right, value after opting out the mean. So this is how, see, in the Vernier caliper, right, the same formula we used 3 times. 0.59 is a perfect answer. The diameter of the cylinder is measured into the Vernier caliper, right? Is measured into the Vernier caliper with no zero error. It means we have to only calculate the main scale plus Vernier scale reading. It is found that zero of the Vernier scale that lies between 5.1 and 5.15. The Vernier scale 50 divisions is equivalent to 2.45. See, I'm talking about Vernier scale from 0 to 2.45 centimeter, right? 50 divisions are there on Vernier scale. How much division? 50 divisions are there. Then I must say 1 VSD, that will be equivalent to 2.45 whole divided by 50. This is gonna be, right, 0.49 centimeter. Right, this is gonna be how much? 1 VSD, it is gonna be 0.49 centimeter. Okay, the first thing is successfully completed. Now 24th division exactly coinciding. Okay, it's okay. Now what about 1 MSD? Okay, see here. In between 5.10 and 5.15. This is going to help us in defining the 1 MSD. Right? Okay. So first of all, what is an actual formula? 1 VSD is got, right? Okay, see, the actual reading states that, right, MSR plus VSR. The main scale lies between 5.1 to 5.15. It means the, see, 5.1 or 5 on the left, always take the value that is on the left side. If the scale is in between the two values, now always take the values that is on the left side. Right, so it means the main scale reading, it is going to be 5.10 plus the VSR, that is n into the least count. Right, so it is gonna be 5.10 plus what is the value of n? The 24th division is coinciding. Here no zero error is there, so I haven't returned into least count. Least count, it is 1 MSD minus 1 VSD. Right, so this is 5.10 plus 24 into 0 of Vernier scale lies between 5.10 to 5.15. If you are analyzing these two values, then 1 MSD you are going to get it as 0.5. 5.10 plus, right, 24 into 0.01. Right, 0.01. Okay, one thing that we have done an error, right? Actually here we are getting 0.049. I'm sorry for that. Here we will get 0.05 minus 0.049. So it will be 24 into 0.001. Final answer we are going to get 5.124 centimeter. This was a small error. I rectified and corrected it. Okay. So B is the perfect answer for this specific question. The fourth question homework from my side, you have to do it by yourself and answer for this question, right? You should answer beneath the video. Okay, so I'm moving aside on the countdown of 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. That's it. Now let's move on to the, see, if you are completely aware of what actual the Vernier caliper is, right, then it is not as much difficult, right, to understand the concept of micrometer screw gauge. it is up to 3 or more than 3 decimal places. What is the main application of the micrometer screw gauge? It is used to measure the diameter of the sphere. It's like Vernier's caliper. The caliper, we were having 2 scales. Here also we are having the 2 scales. But things are a bit different. Formula is same, right? Everything is same, but the calculation of the least count is a bit different. For that, we need to see the construction of the micrometer screw gauge, right? Okay, see. Beyond, at the edge, we are having one thing that is to be right grabbed, and the circular scale is rotated. That thing, it is known as ratchet. Okay, we are having the 2 scales into it. The first one, it is known as a main scale. The scale is fixed. Divisions on the main scale are known as main scale divisions. It is fixed. The second scale we are talking about, right? Vernier scale. Sorry, the circular scale. The circular scale. The main scale, the circular scale. The main scale, the circular scale. Circular scale is the movable scale. And the divisions on the circular scale, they are known as circular scale divisions. CSD, MSD. Right? With the main scale, one spindle is attached. Right? With the main scale. One spindle is attached like this way. One spindle is attached. This spindle is movable spindle. This spindle is movable spindle. Right? Now what happens here? Using the ratchet, the circular scale is rotated. Here object is kept. Okay, here the object is kept to measure the diameter. This is an object kept. Okay, with the help of the ratchet, slowly it has been rotated, and the spindle is trying to move. The spindle moves forward and grabs the object. Grabs the object. If you have seen into the experiment, right, the lab assistant always used to say, when you heard 3 times, tuck, 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 things are fixed. Beyond this, error is going to come. Those who have appeared for an experiments, they might be aware of. Right. So this is an actual construction, and you should be aware of what terms? Least count and everything that is going to come. Now, what is a least count? Before moving on to the least count, you have to understand the actual definition of pitch. What is a pitch? Right? distance covered on main scale on rotation of circular scale once. When you are rotating the circular scale once, how much distance, how much linear distance is covered? Now see, this time we want a relation between the one thing that is getting rotated and the circular, and second that is right moving forward and backward. So in between, if you want to find the relation in between two, we need a reference line, right? So this will be our reference line with respect to which all of those readings, right, we are going to calculate. The reference line with respect to which all of those readings we are going to calculate, right? Distance covered on rotation of one circular scale by 360, on the rotation of the circular scale by the 360 degree. How much distance is covered on the, how much linear distance is covered on the main scale? This is main scale, right? This is circular scale. If circular scale is rotated by 360 degree, how much linear distance is covered? It is known as pitch. How much linear distance is covered? It is known as what? Pitch. So distance covered on the main scale on the rotation of the circular scale, it is known as pitch. Right? What will be the least count? First of all, let's calculate the pitch. A screw gauge has the least count of 0.1 mm and there are, okay, least count. What is the least count? Pitch is not a least count. Right? You all might be thinking like you are having the misconception into the Vernier caliper in the, right, that 1 MSD is the least count. No. 1 VSD is the least count. No. Actually, difference between 1 MSD and 1 VSD is the least count. Here, on rotation, see, least count is what the minimum value that we can, the smallest value that we can measure through an eye. On rotation of the one complete degree, 360 degree on rotation, on having the one complete rotation, the linear distance covered is a pitch. Is it the smallest value? No. Suppose if I am rotating the 360 degree, can I rotate it by 1 degree, 180? Distance will be half. Can I rotate it by 90 degree? Distance will be 1/4 as compared to the one complete rotation. Can I just click? Tuck. On rotating the circular scale, just tuck. Not 360, not 180, not 90, no. Just I'm about to start. On that position, the number, the linear distance covered on the main scale is the least count and is the smallest value. It is the smallest value, right? A screw gauge has a least count of 0.1 and there are 100 divisions in its circular scale. What is pitch? Directly we are going to use up the formula, right? Least count, that is equal to number of divisions, right? Whole divided by, okay, the least count, that is number of divisions whole divided, pitch divided by number of divisions on the circular scale, right? Okay, then pitch is equal to least count, how much? 0.01 mm into 100. So that is equal to, then the pitch of the screw gauge. 100 divisions on the circular scale, na? So this is going to be 10 to the power minus 2 into 10 to the power 2. It is going to be 1 mm. Pitch is going to be 1 mm. Right? Least count, okay, it's all we are aware of. Zero error. I told you about one thing that is rotating. Second, we are covering a linear distance. So in between this two, we need a reference part. that will be our reference line. This is right the main scale, this one is a circular scale. Now basically formula of the zero error is going to be same only, right? Zero error, that is equal to nth division that coincides into least of count. This is when object is not kept. Now this thing is not new, you all are aware of. Zero of main scale is exactly coinciding with the reference line, is right, comparing it to the circular scale, no zero error. Zero is beyond, zero of circular scale is beyond the main scale. We are having positive error that is going to subtract from the reading. If zero is above, right, this is circular scale, this is main scale, then we are going to get the negative error. This is the same thing that we have seen into the Vernier Caliper charts 15 to 20 minutes before, right? Okay, just the way of the calculation is different. In that both were moving into the linear manner. Here one scale is rotating and second is moving into the linear. Or on the second is fixed, but on the second the distance is covered into the linear manner. What is an actual formula? Simple. Two scales, right? So the actual reading states that main scale reading plus circular scale reading, okay, minus zero error. This is the formula of the actual reading. On basis of this, right, directly we are going to see upon the sums. Screw gauge gives the following readings, which is used to measure the diameter of the wire. Main scale reading is 0. Circular scale reading 52 divisions coinciding. Given that 1 mm on main scale corresponds to 100 divisions on the circular scale, the diameter of the wire will be what? First of all, we are going to calculate the least count. What will be the least count? Right, that is equal to pitch whole divided by number of divisions on the circular scale. Pitch is of 1 mm, number of division is 100, it's 0.01 mm, this will be the least count, right? 0.01 mm, this will be the least count, right? Now what is an actual formula? Actual reading, that is equal to main scale reading plus circular scale reading, right, minus zero error. What is the main scale? It is given as 0. Circular scale nth into the least count minus zero error. Are we having any kind of the zero errors? Okay. It is not mentioned. It means we are not having zero error, right? It is not mentioned. So it is going to be number of the divisions, how much, right? 52 into the least count, right? Number of the divisions, that is equal to 52, right? Are we missing something? Circular scale reading is 52 divisions, 1 mm, okay. The diameter of the wire will be what? Okay. So 52, right, into least count, that is 0.01, right, mm. So you are going to get 0. Right, 152 mm. So it is nearly equivalent to 0.5 mm, right? It is nearly equivalent to 0.5 mm. This is the perfect answer for this specific question. A student measured the diameter of the small steel ball using a screw gauge of the least count. See, least count is given. The main scale reading is of the 5 mm and the 0 of the circular scale division coincides 25. Above 25 above. 0 of circular scale divisions coincides with 25 division above the reference level. Zero error is negative. Correct diameter will be what? Direct formula we are going to use. Actual reading, that is equal to main scale reading plus circular scale reading minus zero error. So the main scale reading is how much? Right, 5 mm. Want to take it into the centimeter? Yes, everything is a centimeter. Let's take it into the centimeter. 0.5 centimeter main scale. 25 divisions coinciding. Least count is 0.001. Right. Zero error is negative. So it is negative of 0.004. So it is 0.5 plus 0.0. Right, I think it is 0.029. Okay, so this is gonna be 0.529 centimeter. D is a perfect answer for this specific question. Right, this is how things are getting calculated. These two sums I'm going to give you all. It's okay, you can do or not. But apart from these two sums, right? Okay, nice sums are there into the. Okay, these things are there, right? These things are this thing will be there, right? If you want, okay, let's solve it. Okay, we'll have a practice about it. Two full terms of the circular square cover the distance of 1 mm. 1 mm. 2 rotations. 1 mm, 2 rotations, but pitch is on the 1 rotation. It means pitch is of 0.5 mm. Total number of the circular scale division is 50. N is 50. Least count we are going to get it as 0.5 whole divided by 50. Right? So it is a 5 into 10 to the power minus 1 whole divided by 50. 5 into 10 to the power 1. Right, so it is going to be 10 to the power minus 2 mm. This will be the least count. Right, zero error is given as this way. Okay, directly we are going to move on for the actual reading is MSR plus, right, CSR, okay, minus zero error. Right, main scale reading is of the 3 mm. Okay, we got it 3 mm plus. Which division? 35 the division coincides. So it's 35 into least count 0.01 mm minus zero error. Zero error is what? Negative. It means 0.03. It is mm, right? So it is 3 plus 0.35 plus 0.03. Okay, so it is approximately going to be 3.38 mm. Okay, D is a perfect answer. The same formula we used. The pitch is this is 100. Least count 0.5 whole divided by 100. 0.5 into 10 to the power minus 2 mm. Right? So it's 0.005. This is the least count. When screw gauge is fully tightened, without any zero with circular 3 divisions below, right, it means we are having the positive zero error, right? Zero error is positive n into least count, right? 3 divisions below, so it is 3 into 0.005. Readings of the, okay, 5.5 mm and 40. Okay, now actual reading is equal to MSR plus CSR, right, minus least count. MSR plus CSR minus least count. Actual reading is 5.5 mm plus CSR. CSR is 48 into 0.005, right, minus, right, 0.015. Or you can say this is also as 5.5 plus 45 into 0.005, right? Okay, Yes or no? So the final answer, it is going to come upon as 5.725 mm. This is the perfect answer. This is how things are getting calculated, right? So rather than to give on to the homework, we solved it here only. Okay, so thank you guys. It's time to go. Okay, so this was all the main part, right, of the this thing. And apart from this, guys, one significant figures are there. Significant figures are quite simple thing, right, that you have done into the chemistry also, and lots of times we have seen on this session into the champion series and everything, right? It's a very small topic of 5 to 10 minutes, right? Okay, so I think, okay guys, so that's it for the units and measurement. Hope so you like that teaser. I will be waiting for all of your the comments right beneath the video. Okay, I will be waiting for all of those comments beneath the video. Okay guys, it's time to go. This is Indrajit Singh signing off from the desk, right? Let's wait for the teaser of the next time. So this is Indrajit Singh signing off from the desk. Bye bye. Sat Sri Akal and Namaste from my side, Bacha ji. Bye everyone. Stay at home, stay safe, stay healthy amidst this pandemic. Bye Bacha ji.